Kangaroo Math Competition 2019, grade 9 to 10. Question 20. The diagram shows a net of an octahedron. When this is folded to form the octahedron, of which of the label line segment will coincide with the line segment marked with the X? Let us start with three quotations from three Nobel Prize winners. Quotes from three Nobel Prize winners. Number one, some great ideas are needed here. Paul Dirac, who ended his book with this remark. Number two, if you want to have good ideas, you must have many ideas. Linus Pauling, who discovered the helix for DNA. Number three, use simple language. Avoid jargon. If you stumble, you have found a gap. Richard Feynman. Let's do some warming up for the brain. How many edges are there in the octahedron? First reasoning, direct counting. There are 4 sloping edges for the upper pyramid and 4 sloping edges for the lower pyramid. There are also 4 edges forming the square. Hence, there are 12 edges. So we count the edges directly. Second reasoning, and indirect counting. There are 8 triangular faces. Each triangle has 3 edges. So 8 times 3 will be 24 edges. But we know each edge belongs to 2 faces. If you look at an edge, there are 2 faces joining at the edge. So each edge belongs to 2 faces. So number of edges, 8 times 3, 24, divided by 2 is 12. Third reasoning. We count the vertices. There are 6 vertices. 2 vertices are vertices of the pyramid, and 4 vertices forms the square. 6 vertices, each vertex has 4 incident edges. If you look at the vertex, there are 4 edges incident on the vertex. If you look at the vertex on the square, there are 2 sides of the square and 2 slant faces incident on the vertex of a square. So each vertex has 4 incident edges. 6 times 4, 24. But each edge connects 2 vertices, and edge connect 2 vertices. So 24 divided by 2, 12 edges. So there are 3 ways to count the edges, either directly counting the edges or indirectly counting the faces to help obtain the number of edges, or we can count the vertices and then calculate the number of edges. The second most beautiful formula in mathematics. This is voted by several mathematicians in the 1900s. V minus E plus F equal to 2. V is the number of vertices, E number of edges, and F number of faces. So V minus E plus F, 6 minus 12 plus 8 equal to 2. Now, all these exercises can help us now try to answer the question. We want to know the each mark X joined to which of the 5 numbered vertices, 1, 2, 3, 4, or 5. Here is the net consisting of 8 triangles that we want to fold to form the octahedron. The XH we want to see will be joined to which of the 5 edges numbered 1, 2, 3, 4, 5. We label the other remaining edges A, B, C, D, F, G, K, J, and L. Then we have the 2 important vertices. We start with the vertex V. Vertex V is pulled up to form an upper pyramid. The edges A, B, C, D, F become sloping edges. V is the vertex of the pyramid. So A, B, C, D, and E will be sloping edges, and A joins E. A joins E. Then, if we look at each triangle, they have a base 3, 4, 5, and F. 3, 4, 5, and F form a square. A diagram will help visualize this. The face in green will be, the base is 5, C and D are the edges for the green triangle. The 2 gray triangle, one on the left and one on the right, with 4 as the base for the one on the left, and sloping edges B and C. The one on the left, the gray triangle, have F as the base and D, and then A and E join to form the H. The unshaded triangle have edges A and B, sloping edges. So 3 is the base. 3 is the base. So the square are formed by the edges 3, 4, 5, and F. Now we consider the other half of the net. Vertex U is pulled up to form an upper pyramid. G, H, J, K become sloping edges. When you pull up U to form an upper pyramid, the edges G, H, K, and J will be sloping, and H joins L. And this helps us visualize X, 1, 2, and F form a square. Because they are the base of the triangle, V is pulled up to become the vertex of the upper pyramid. So X is the base of the sloping face, blue, dark blue. 1 is the base of this light blue triangle on the right. Then the yellow face is, the base is 2, and the edges G and J. And the blue triangle will have F as the base with sloping edges G and H. Then we can sketch a diagram. So the dark blue triangle, X is the base. See the vertex U, the H and L join. K is the other side with X as the base. We can visualize U is the vertex, therefore X is the base. Similarly, 1 is the base for the blue triangle on the right, and F is the base for the blue triangle on the left, and 2 is the base for the yellow triangle, which is hidden and not seen in this diagram. It has the sloping edges G and J. So 2 is the one of the edge that forms the square X1FJ. X1FJ form the edges of the square. Then we can rotate around the HF. The HF, this edge here that divides the network into 2 halves. So we can rotate the pyramid on the right so that the vertex U will now be pointing downward to give us a lower pyramid. U is now pointing downward, and we can see the yellow triangular face at the far side. So the X F2H, we realize F is on the right now, and after the rotation, the H1 is now on the left. Similarly, the edges, slant edges, also switch position. J switch with G, then HL switch with K. Yeah? So we are now ready to join the 2 pyramids, the upper and lower pyramid, and we can see that the HX joins the H number 5. HX is joined to H5. Let us study the problem further. These were the edges that were labeled just now. And then the vertex V and U. And the mathematical objects that were used, we have triangular faces, we have edges, vertices, and also we have the solid octahedron to help visualize. This is a cutout showing 1/2 of the net is being folded to form the upper pyramid. The H5 is the base of the triangle facing the front. Then we have F3 and 4. The edges C and D can be checked. B, A, and B. A joined to E, and then we have A and B form the sloping edges for the base H number 3. Yeah. Now we can picture folding the other half of the octahedron. So the edges G, H, L, and K, and J, they form the sloping edges. H will join to L. Therefore, X, 1, 2, and F form the square. X, 1, 2, and F form the square. So now we can rotate around the edge F, and it can be seen X will be joined to H5. End of the video. Thank you for watching.